Hey guys, welcome to the worked answers for the 2020 Level 2 Algebra paper. Let's get into it. So question 1, we've been asked to factorize this quadratic 6x squared plus 13x minus 15. We've got 6x squared plus 13x minus 15, and our a value is greater than 1, it's 6. Meaning we are going to multiply a by c, so that is 6 times negative 15, and that will equal 60 plus 30, so negative 90. And so we're looking for two numbers that multiply to negative 90, and the same two numbers that add to the b term of the quadratic, which is 13, and those two numbers are positive 18 and minus 5. So we're going to say 6x squared. We're going to split our b term up now, plus 18x minus 5x minus 15. So you can see here positive 13x has just been rewritten as 18x minus 5x. Okay, now we split the quadratic into two halves. Factorize the left-hand side. 6x is a common factor, and then x plus 3 inside the brackets, and then minus 5 is a common factor, and x plus 3, and you know you're on the right track when these two sets of brackets are the same. So we've got 6x minus 5 times x plus 3, and that is our factorized form. Now there is another way you could have done this. You could have gotten your calculator and basically gone ahead and plugged in the numbers a, b, and c, 6, 13, and negative 15, and you can solve your quadratic. Our x values come out as x equals 5 over 6 and negative 3. And so when that's the case, we could have said, basically looking at this first one here, x equals to 5 over 6, we could have rearranged and said 6x minus 5 equals 0, and we see that's as one of our brackets here. And similarly, if we had x equals minus 3, then it would have become x plus 3. And this is our second bracket here. Okay, so here, correctly factorize 6x minus 5 times x plus 3 gets you the achieved here. Okay, moving on to question 1b now. It says a function is defined as f of x equals x squared plus 10x plus 22. Express f of x in completed square form, i.e. f of x equals x plus a all squared plus b, where a and b are integers. So here we are completing the square. This is our function, f of x equals x squared plus 10x plus 22. And so the first thing we are going to do is we are going to divide the b term by 2, so 10 over 2 equals 5. And so 5 squared, hopefully this is maybe familiar work. 5 squared is 25, and so that means we are going to add 25 on both sides of our equation here. So x squared plus 10x plus 22 plus 25, and that equals 25. At this point, we can say x plus 5 all squared, x plus 5 all squared. Now that would make up these three terms, the x squared, the 10x, and the 25. And so we've got plus 22 left over, so we can say plus 22 equals 25. And so rearranging, we want it in x plus a all squared plus b form. So we're going to say x plus 5 all squared, and we're going to bring our 25 back over now to the left-hand side. And so it's going to become 22 minus 25 is minus 3. Okay, and with that we have completed the square correctly, and that gets us the achieved grade here. Multiple ways of going about that sort of question, but that is how I like to do it. Okay, moving on to question 1c now. And it reads, in the 16th century, mathematicians were developing a formula to solve any cubic equation. They used expressions in the form of y equals x cubed minus 12px plus r, where p and r are positive constants. The graph of y equals x cubed minus 12px plus r for some values of p and r passes through the point A, which is 440, and is sketched below. So we've got this sketch here. And the question asks us to find an expression for p in terms of r. So just to get us started on this question, CI, they're just asking us to rearrange. So our graph is y equals x cubed minus 12px plus r. And it's asking us to find an expression for p in terms of r. And we have p and r. We also have this variable x, but we can eliminate that. And we also have y. But we can eliminate those two variables, x and y, using the point A, which is 440. And we can use that because, as it says in the question, this graph passes through the point 440, meaning we can substitute, and actually we see it here as well, don't we? We can substitute 440 into our equation, eliminate x and y, and then find an expression for p in terms of r. So 4 is our x value and 40 is our y, and so we are going to say 40 equals 4 cubed minus 12 times p times 4 plus r. Okay, we can tidy this up. We can say 40 equals, now 4 cubed is 64, minus 12 times 4 is 48p, plus r. So we've successfully gotten rid of x and y. We now need to rearrange to make p the subject. Okay, and so we can say, let's bring 48p to the left-hand side, making it positive. So we've got 48p. 64 minus 40 is 24, and plus r. And so divide by 48 on both sides to get p by itself. So we've got 24 plus r over 48. And so that is our correct rearrangement here. finding an equivalent expression for P in terms of R gets you the merit grade. Your achieved comes from substituting correctly. So just our first step here should get you the achieved, substituting the point A 440 into our equation. Okay, moving on now to question C2. At point B, it is true that 3x squared minus 12p equals 0. Using algebra, show that x equals minus 2p to the power of 0.5 at B. Okay, so we've got 3x squared minus 12p, and we actually don't need to look anywhere else to work towards finding this answer here. It talks about point B in the question and point B here, so basically we've got all the information we need, and actually it's just a rearranging question in disguise. So they're asking us to show that x equals minus 2p to the power of 0.5. So here let's just make x the subject and see what happens. So we can say 3x squared equals positive 12p. Let's divide by 3 on both sides, so x squared equals 4p. Now we have to square root. The opposite of squaring is square root. So root of 4p. And so this equals plus or minus 2p. And rather we could write this as plus or minus 2 root p. Okay. And knowing our indices rules, if we have root of x, that can also be written as x to the power of a half, which also equals x to the power of 0.5. And that's what they're getting at in our question here with the minus 2p to the power of 0.5. So we've still got plus or minus here. We'll address that in the next step. Plus or minus 2p to the power of 0.5. Okay. Now, the question is asking us to show that x equals minus 2p to the power of 0.5 at B. We have plus or minus 2. So let's just look at our graph now. We go back up to our graph, and we see that B sits on the left side of the y-axis, meaning it is a negative x value. Okay, so all the values going this way are minus x, for example. All the values to the right are positive. So we've got, instead of minus x, we could say, negative and positive. Okay. Likewise, if we're looking at the y values, this is positive, and this is negative, okay? We know that. Anyway, point B has a negative x value here. And so when we're talking about x, okay, that's what we're solving for, x equals, we need x to be negative, and the only way we can do that, because p to the power of 0.5 will be positive, meaning the only way we can make x negative here is by going x does not equal plus 2p to the power of 0.5. Let's just say at point B, because that's the context that we're working towards, or working with rather. At point B, x only equals negative 2p to the power of 0.5. Okay, and with that, we have done correct working and mathematical statements, including an explanation for only using the x value. They're on about including explanation. The marking schedule mentions, they've said point B has a negative x value. Okay, so that is, a necessary statement. We can put that in brackets. Okay. Anyway, excellence for this question. Your merit comes from finding x equals plus or minus 2p to the power of 0.5. So this step here is your merit. And achieved correctly solving the equation to the point where x equals 2p to the power of 0.5, or x equals 2 root p, or x equals plus or minus 4 root p. Sorry, root 4p. So what is our earliest achieved that we can get? It is going to be, I think here is your achieved. Okay. Moving on to question C3 now. It asks us to consider again the curve with the equation y equals x cubed minus 12px plus r. As the values of p and r vary, the shape of the curve changes. The length of the orange lines, and the central blue line, and we're seeing this in our diagram, below, vary. However, by symmetry, the two orange lines remain the same length as each other. Right. It says some examples of the graphs obtained from various values of p and r are illustrated below. Again, we've got this. For some combinations of p and r, the curve can intersect the x-axis 3 times. This will happen if each orange line is longer than the blue line. And finally, we get to the actual question. Find the condition that p and r must satisfy for the graph to have 3 distinct x-intercepts. Write your answer in a form where the exponents of p and r are both positive integers. Okay, so an extremely long question here. Let's try to basically summarize and decide what we're going to do. They are asking us to find the condition that p and r must satisfy for the graph to have 3 distinct x-intercepts. Now, when is that the case? Apologies. Just a moment. Okay. So, it says for some combinations of p and r, we can intersect the x-axis 3 times. This will happen if each orange line is longer than the blue line. Each orange line is longer than the blue line. So, for our little situation that we're working towards, orange is longer than the blue line, and so we can say orange is greater than blue. Okay, now, what to do now? Let's just write down our equation. We've got y equals, it was x cubed minus, I believe, 12px plus 2, was it? I have to check this. X cubed minus 12px plus r. Oh yeah, that's right, r. Okay, plus r. Now, the critical idea here is that thinking of graphs, we have r, and that is the constant of the graph. Now, what does that represent? The constant represents the y-intercept in this case. And so that means r is from the x-axis up, it is this measurement, and that is r, meaning we can see that r is the blue line. That's the key thing here. R represents the blue line. And so we can say blue equals R because y-intercept. Because y, not g, y int. Okay, still, how do we make progress here? Well, another formula we can say, or we can use, is we can say, looking back at our graph now, the orange line, which is obviously here and here, let's work with the left one. We can say, and we're not using any maths here, we're just looking at the graph. Let's just draw this across. The orange line equals the point B up the top here minus the blue line. Okay, because this is what we're getting at. We've got our blue, we've got our R. This is, for example, let's say this was point B. We have this length here is orange, and I understand it's getting a little bit messy. Orange. Okay, we've got our R. Okay, and point B. Okay, that's a lot to take in, but let's go ahead and look at some of the maths. We're going to say orange equals B minus blue. Okay? And so we're going to say, we're going to substitute point B into our equation. Okay, y equals, now what was point B? I believe that was minus 2 to the power of 0.5, right? Yep, minus 2p to the power of 0.5. B equals minus 2p to the power of 0.5. And again, I understand that it's sort of going all over the place here. Let's say substituting the value for x, because this is the x value at point B, right? Again, we can highlight it. This is our x value at point B. We can see that here. Okay, so let's say y equals 2p to the power of 0.5. That is cubed minus 12 p to the power of minus 2p to the power of 0.5 and plus r. Okay, tidying this up, we can say minus 2 cubed is going to be minus 8 p, and then we've got powers on powers for the 0.5 times 3, so 1.5. And we've got positive 24 multiplying, we're multiplying this bracket now. positive 24, and then p, we're multiplying the two p's, meaning we're adding the indices, so it's going to be p to the power of 1.5, and this is plus r. Now we've actually got like terms here now, minus 8p to the power of 1.5 plus 24p to the power of 1.5. So we can add them up, and we can say 16p to the power of 1.5 plus r. And now we will look towards what we were getting at before about the orange equals orange equals b minus blue. Okay. So we can say b minus blue is going to be, now it's crucial to remember, this is y. Remembering that this is a function, this equation here is a function, and we had substituted in b equals minus 2p to the power of 0.5, effectively meaning this is y equals 16p to the power of 1.5 plus r is the value for y. It represents the y coordinate at point B. Okay, so if we're saying orange equals b minus blue, we can say orange equals 16p to the power of 1.5 plus r, and what is blue? Well, we said earlier that blue equals r, so we're going to say minus r. Tidying this up, our r's cancel, and so we're left with 16p to the power of 1.5. Okay, is there anything more to do here? Well, according to our inequation, we want orange to be greater than blue to satisfy this idea of three distinct x-intercepts. We want orange to be greater than blue. We have a value for orange, we have a value for blue, it's r, and so we are going to say that we want 16p to the power of 1.5 to be greater than r. Now we could do some rearranging here, remembering that they're asking us to find a condition that p and r must satisfy, writing our answer in a form where the exponents of p and r are both positive integers. So let's just rearrange for p in this case, because we've got a value for r. We also need to find a value for p. And so we can say p equals 1.5. Sorry, p to the power of 1.5 is greater than r over 16. And 1 to the 1.5 can be written as 3 over 2. Now that is obviously fractional indices, power over root. Okay, so we could rewrite p here and say p to the power of 3 root equals, greater than r over 16. So we're trying to find p by itself. We can take the root to the right hand side. We can say p cubed is greater than r over 16 all squared. Now, interestingly, the marking schedule doesn't take this any further. And I'm just thinking about the question. Exponents of p and r are both positive integers. I might have gone on and said p is greater than the third root of r over 16 all squared. I probably would have gone on and said that. The marking schedule stops at p cubed is greater than r over 16 all squared. So I too will stop. If possibly someone in the comments wants to enlighten me as to why this is the case, then please do. Anyway, correct result here derived with correct mathematical statements gets you the excellence here. Okay, your merit is recognition, this is excellence, 2 points for the excellence, T2, let's call it. They use a T for representing an E. And T1 is recognition and statement that 16p to the power of 1.5 is greater than r. So this was also excellence. Let's use E1. No, let's keep the same theme and just say T1. Okay, your merit is length of the orange line obtained. And possibly this will clear up some of the issues I had with explaining it. The length of the orange line was 16p to the power of 1.5, so this was here. Okay, quite the question, that one. No achieved, by the way. The marking schedule does not have any criteria for achieved. Possibly you would have gotten some achieved marks along the way, but for credit, but the marking schedule doesn't mention anything. Anyway, I'm glad to move on from that one, and let's move to question 2. So it says, write as a single logarithm in its simplest form, log 9y plus log 4 minus log 3y. So we've got log, as always, we'll just write out our question, log 9y plus log 4 minus log 3y. So standard just log rules. If we're adding logs, that means we multiply the brackets. So this looks like log, we combine the two logs and we say 9y times 4, which is 36y. And then minus log 3 still there. And so this equals, now we're subtracting logs, meaning we divide what goes inside the brackets. So log 36y over 3y, and we can simplify this and say log 12 here. The two y's cancel, the 3 cancels, and the 36 becomes 12. Okay, and for this question, you will get, correct solution gets you the achieved. Okay, moving on to question 2bi now. We've been asked to solve each of the following equations. Log x 36 equals 2. Log x 36 equals 2. And so this can be rewritten as x squared equals 36. I'd rather not go into writing all the formulas for logs. Hopefully you've done a bit of log work and this makes sense. So now we're going to say x equals the root of 36. And so x equals plus or minus 6, but x x cannot equal 6 because you cannot have negative bases for the logs. X does not equal negative 6, therefore x equals just positive 6 only. Okay, this correct solution gets you, again, an achieved. Moving on to question 2b2 now. We've been asked to solve this equation, log 5x plus log 5(2x) equals 4. Okay. Log 5x, that is, plus log 5(2x) equals 4. We can collect like terms on the left-hand side. They both have base 5, so we're allowed to do that. So this becomes log, we're adding, meaning we multiply the brackets, basically, if we were to draw some brackets in here. Log 5 times 2x squared, because x times 2x is 2x squared, this all equals 4. Okay, and now what do we say here? We can say 5 to the power of 4 equals 2x squared. It looks odd, but that's exactly the same rule we are using here. X squared equals 36. We've said 5 to the power of 4 equals 2x to the power of 4. Now let's calculate a 5 to the power of 4. That equals 625. Equals 2x to the power of 4. We can divide by 2. Equals 312.5. Equals x to the power of 4. And now the opposite of power of 4 is the 4th root. Now, how did I get to the power of 4? That's not true, is it? Power of 2. Just looking at my notes. 2x to the power of 2 it was. 2x to the power of 2. So, we want to not take the 4th root of 312.5, but rather we want just the square root. So, 312.5. And that equals 17.68 plus or minus 17.68. That's the value I've got from my calculator. And also, we have to remember that x, the marking schedule writes x must be greater than 0. I'm going to say x can't be, now is that true? X can't be negative. Again, it's one of these things that I'm foggy on. I was going to say x can't be negative. Just for reference, the marking schedule says x must be greater than 0. Now those are slightly different statements. Obviously, the point about whether it can be 0 or not. Anyway, the marking schedule mentions x is greater than 0. So therefore, the only solution, therefore, x equals positive 17.68. It's one of those things that, looking at the marking schedule, correct solution with negative value rejected. So they've explicitly said negative value rejected. So yeah, I assume I'm right there. Anyway, this, believe it or not, gets you an excellence, a T1 excellence, that is. Your merit is finding x. So here, merit, and your achieved combines logs in a valid way. So I think this step here, a fairly easy achieved for this question. Okay, let's move on now to question 2C. We've been asked to solve the equation. We've got two fractions here, 5x plus 4 over x plus 4 minus 3x minus 4 over 2x plus 1, and this equals 0. Okay, so it might not look too difficult, but we'll probably get into some fairly long workings here. 5x plus 4 over x plus 4 minus 3x minus 4 over 2x plus 1, and that equals 2. Okay, we've got no choice here but to cross multiply, and that's what we're going to do. So we are going to multiply diagonally, and we're going to multiply the denominators. Okay, so let's give it a go. We've got 5x plus 4 and 2x plus 1. And we will combine into a single fraction straight away. There's no need to have two different fractions. So that's minus 3x minus 4 and x plus 4. And this is all over multiplying the denominators, x plus 4 and 2x plus 1. Okay, and that equals 2. Now we can tidy these brackets up, tidy up the whole left side, that is. We'll expand our brackets. Obviously, when I talk about expanding, we're using the FOIL method, so first, outer, inner, and last, multiplying. Okay. And so we'll just go for it. We've got 5x times 2x is 10x squared. Positive 5x plus 8x is going to be positive 13x and plus 4, and minus 3x squared plus 12x minus 4x is plus 8x and minus 16. So that's still in brackets. This is all over, and we can expand our denominator. 2x squared plus x plus 8x is plus 9x and plus 4, and again this all equals to 2. Okay, so let's expand this bracket and collect like terms at the same time. We will also be multiplying by 2x squared plus 9x plus 4 in order to cancel out our denominator. Effectively, we're going to be taking it to the right-hand side. Okay, so scrolling down a little bit. Okay, we've got a lot of room here. We're going to say 7x squared, and yeah, also we could highlight it, collecting like terms, right? X squareds, x's, and just the integers, so 4 and the 16. So I've got 7x squared, 13x minus 8x is positive 5x, and positive 4 plus 16 is 20. And this equals 2 times 2x squared plus 9x plus 4. Okay, so we can see a quadratic starting to form. Let's keep going. We've got, we'll leave the left-hand side as it is for now. 7x squared plus 5x plus 20. We can expand our bracket on the right hand side, 4x squared plus 18x plus 8. Okay, now let's take everything to one side. We'll take it all to the left hand side just to keep our x squared term positive. It makes it a lot easier. So again, we're collecting like terms. We've got x squareds, x's and integers, 20 and 8. So it becomes 3x squared minus 13x, and positive 20 minus 8 is minus 12. Sorry, positive 12, and that equals 0. And at this point, we are going to factorize. Now, we could do it the long way, 3 times 12, two numbers that multiply to 36 and add to negative 13. But we've done a lot of working. We have our calculators with us. Let's just use our calculator here. We're going to plug in values for A, B, and C on our, well, I'm using the Casio FX99 1EX. I've clicked mode 5 for equation, 3 for quadratic, and I've got 3 minus 13. Basically, it's the quadratic solver on the calculator. Okay, and we are going to come out with x values of x equals 3 and 4 over 3. Okay, and those two are our correct solutions. So this gets you a merit. Your achieved is, and I quote the marking schedule, begins to handle denominators in a correct way. In brackets, they say adding their fractions using a common denominator or multiplying through by one denominator. So they're talking about the denominators. Adding the fractions using a common denominator or multiplying through by one denominator. Okay, so I want to say the step here will get you an achieved. Okay, let's move on now to question 2D. It says consider two parabolas. Parabola 1 given by y equals ax squared plus bx plus c, and parabola 2 given by y equals dx squared plus ex plus c, and they're all constants. Use algebra to determine the restrictions on the values of a, b, c, d, and e that would ensure that the parabolas meet at two distinct points. Well, the key piece of information that we are going to work off here is this idea that they meet. First of all, they meet. And so when they meet, we can say y equals y. Now we have values for y. It's ax squared plus bx plus c, and that equals dx squared plus ex plus c. Okay. Let us bring everything to one side now. Similar to the previous question, actually, ax squared, and we'll order it in descending powers of x, so minus dx squared plus bx squared, just bx, minus ex, and our two c values we can see cancel out. Okay, and this equals 0. At this point we can take some common factors. We can take a common factor of x squared. Basically we can split our quadratic in two like that. Okay. We can take a common factor of x squared, and it becomes a minus d inside the brackets. And we can also take a common factor of x, so it becomes b minus e. And it equals 0. again, we can take a common factor of x this time. X, we've got x, a minus d plus just b minus e here. And this is obviously all inside brackets. And this equals 0. Okay, this is fairly straightforward. Hopefully it makes sense. Using our knowledge of equations in factorized form, straight away we can say that x equals 0. Okay, and that's this x here. It's like saying x times x plus 3. This was an equation I looked at the other day in MCAT, equals 0. Straight away we can say that x equals 0. And that's that x there. Obviously our other solution would be minus 3. Okay? Now, what's inside the brackets is a little bit more complicated. And let's write this. We've got x times a minus d plus b minus e. And that equals 0. Okay, so we're wanting to rearrange for x. And so we're going to say let's say x times a minus d, and we'll take the b minus e to the left hand side, so it becomes minus, and you don't necessarily have to keep it in brackets. I have just for the sake of consistency here. We'll expand the brackets in a moment. We've got x equals minus b plus e. We'll give ourselves a little bit more room. And this is all over a minus d. Okay, just tidying it up, we can say e minus b, so just putting the positive numbers first, over a minus d. So these are our two values for x. Okay. Now, are there any constraints here? Well, we do have some constraints. Just looking at the question, using algebra to determine the restrictions on the values of a, b, c, d, and e. Okay, and again it talks about two distinct points. We have found our two distinct points. At least we found the x coordinates of our two distinct points. Okay, so the x equals 0 we don't really have to worry about. It's the, as it says, the restrictions on a, b, the c cancelled, d and e. What are our restrictions? Well, looking at the denominator, no, let's look at the numerator first of all. Basically, we're not wanting to have 0 in the numerator or denominator. So for our restrictions, we're going to say b should not equal e, because otherwise you get 0 in the numerator. And also a should not equal d. These are our restrictions here. Now, is there anything else to be done here? Just reading the marking schedule, there will always be a second. Yeah, so they talk about a does not equal d, so that it's defined. So that is talking, okay, defined. I think they have differing reasons for why these are the case. And it says b should not equal e, so that second is distinct from the first. Second is distinct from the first, So it says, when it says that, they are talking about one of the equations always being 0, right? That's x equals to 0, always. And so if you had b did equal e, your numerator, it wouldn't be undefined, but it would just be 0. Okay, 0 over something always equals 0. Okay, so they talk about b not equaling e so that the second solution is distinct from the first. And why do they want it to be distinct? Well, that's talking about, going back to the question, meets at 2 distinct points. Again, I'll highlight that piece of information here. Okay, so correct working leading to both of the constraints clearly expressed gets you the e, and not only is it an e, but it's T2. Your T1e is correct working leading to one of the constraints clearly expressed. So, okay, yeah, one of the constraints. So let's just say the first one we said T2 equals T1, and we'll say just 1 in brackets. Okay, your merit is solves the quadratic equation correctly but does not draw conclusions from the solutions. So we've solved our quadratic correctly. That would be our 2 solutions here. Merit achieved sets up the simultaneous equations. Where are our simultaneous equations? They weren't mentioned. Okay, so it's just stating the y equals y, stating that and then setting it up. So achieved here, our very first step. Sweet, that's us for question 2. Let's move on to question 3 now. So question 3a, we've been asked to solve the equation 3 to the power of 4x equals 30. So we've got 3 to the power of 4x equals 30. And here we are going to take log of both sides. So we can say log 3 to the power of 4x equals log 30. Okay, and now using our log rules with indices, we can bring not the 4x, but rather x, because we're trying to isolate x. So let's say this, x log 3 to the power of 4 equals log 30, and that is valid. You can split up the 4x in that way. And here we can say x equals log 30 over log, and we can simplify 3 to the power of 4 into 81, that is. And here let's go ahead and calculate this. We've got log 30 over log 81, and this gives us an answer of 0.774. So 0.774, that's basically 3 decimal places, or you could say 4 significant figures. Here, correct solution gets you a merit grade, not an achieved, but rather a merit grade. Your achieved is expanded log form, so I want to say this step, but I'm not sure. Definitely our second step of working gets you the achieved. Okay, moving on now to question 3b. We've been asked to consider the function w equals x plus 2 all raised to the power of 2 over 5, where x is a whole number. Make x the subject of the formula. So it's a rearranging equation. it says make x the subject. We've got w equals x plus 2, and that's all raised to 2 over 5. And here we're making x the subject. Okay, so the first thing we can do is get rid of our 2 over 5 indices. So we can, there's a couple ways to think about this. One way of thinking about it is raising w to the reciprocal of 2 over 5. So w over to the power of 5 over 2 actually equals x plus 2. Okay. Now, let's take the 2 to the left-hand side. We say w to the power of 5 over 2 minus 2 equals x. And here we have successfully rearranged to make x the subject. The marking schedule mentions x equals, and they've rewritten the fractional indices there in the form, obviously it's power over root, so it is root w to the power of 5, and they've said minus 2. Both answers here are correct, and so correct expression gets you an achieved grade. Okay, moving on to question 3b2. For what values of x will the function have values less than 20? Values less than 20. So what's our original function? X plus 2 to the power of 2 over 5. And w was, consider the function w equals where x is a whole number. Values less than 20. Basically, we're saying here w, we want w to be less than 20, I believe. It doesn't explicitly state that relationship between w and this idea of values less than 20, the function having values less than 20, but that is what we are going to do. We're going to say x plus 2, all raised to the power of 2 over 5, is less than 20. Okay, and so here we are solving for x. Let's do what we did before and say x plus 2 is less than 20 to the power of 5 over 2. And so x plus 2 is less than, and let's calculate that, 20 to the power of 5 over 2 is 1,788. 0.85 even. That's 2 decimal places. And so x must be less than 1788.85 minus 2. Meaning x is less than 1786.85. And that is our correct solution for x here. The answer schedule mentions correct solution for x as a whole number, and yes, I believe that's true, where x, the question says where x is a whole number. So that means we're not quite done. We have to say x must be less than, now you might be inclined to say 1786, but if we say x is less than 1787, then we have included 1786. It'll be all those whole numbers below or less than 1787. Okay, here, correct solution for x as a whole number gets you the merit. Correct solve solution to find x equals 1786.85 is your achieved. So I want to say this step here is your achieved. Okay. Moving on now to question 3C. And it's a big word question. So Zara sells zips. Zara notices that the higher the price of a zip, the fewer zips are sold. As an experiment, Zara increases the price of a zip by $2 each day, starting at $7, and keeps a record of how many zips are sold each day. She does this for 6 days and finds that the number of zips sold each day started at 98 and is dropping by 3 each day. So as she increases the price of a zip, it's dropping. The quantity sold is dropping. The total amount of money Zara received each day for zips, the turnover, is also recorded in the table below. And we've got this table here. C1 asks, if all the patterns continue to be valid, is there any day on which the turnover is exactly $445? Use algebra to justify your answer and explain your conclusion. So our turnover is stated here, this third line. And what makes up the turnover? The turnover will be the price of a zip times the number of zips sold, okay? And yeah, I believe that's the case. We can just check, for example, this line here. We could say 7 times 98 equals 686, okay? So, turnover is, we can state an expression for the turnover. Turnover equals price times, let's say, number of zips sold. And so we have been given equations for the price of a zip and the number of zips sold. So we can say turnover equals 2D plus 5 times 101 minus 3D. So that's our expression for the turnover. Now the question is asking, if the patterns continue to be valid, is there any day in which the turnover is exactly 445? So we are going to substitute 445 into our equation. Okay. Like that. And here, the question is asking for any day. So we're looking to solve for D. So let's go ahead and expand our brackets. We've got 445 equals, and what have we got here? 2 times 101 is 202. D minus 6D squared plus 505 and minus 15D. Okay, so we can collect like terms and take everything to one side all at the same time. Let's bring our... Well, let's take the 445 to the right-hand side. I was thinking about bringing the negative 60 squared to the left-hand side and therefore bringing everything to the left-hand side. But really, it doesn't matter. We can just use our calculator to solve once we've formed our quadratic. So let's say 0 equals minus 6D squared. 202D minus 15D is 187D. And 505 minus 445 is 60 here, so positive 60. Now at this point, let's just use our quadratic solver. So we've got negative 6 is our A term, 187 the B term, and 60. for the C term. And so D must equal, well, it does equal 31.48 and negative 0.32. Now, if we think about the context of the question, D is a variable representing the day, and so we can't have negative days. D can't be negative, and also we need D to be a whole number. Again, we're talking a bit about days here, so D must also be whole. You can't really be dealing in 31.48 days, for example. And so according to these two constraints, there is no day in which the turnover, no day in which the turnover is, and what's the phrasing of the question? Exactly 445. Okay, and that is our correct answer here. So T1 gives a valid explanation as to why the turnover is never $445. So excellence, and that's a T1 excellence. And when I talk about T1, that is basically T1 gives you an E7. And typically, if you get two T1s, you get the E8. If you get a T2, you automatically get an E8. So you can have a look at the marking schedule for Level 2 Algebra and basically make sense of that. Anyways, T1 excellence for this question. Your merit is finding the values of D. So here, your merit, and achieved forms the correct equation for the turnover. So just stating, again, the correct equation here gets you an achieved. Sweet. Moving on to question C2 now. And it says, Zara realizes that not every whole number is a possible turnover value for a given day. Using algebra, find at least three conditions a whole number k must satisfy for it to be a possible turnover for a given day. So our turnover is given by the equation. What have we got here? It is 2d plus 5 times 101 minus 3d, so that's the same as before. And in this case, we are talking about not a set turnover, 445 for example, but we're looking at three conditions a whole number k must satisfy for it to be a possible turnover. So essentially, turnover here is this whole number k. So we can say our expression for turnover equals k. Now, there's no need to go through the whole expansion process again. Let's just look up here. Our expanded quadratic is 202d minus 6d squared plus 505 minus 15d. So let's bring this down to our workings here. And so we've got minus 6d squared. I'm writing it in quadratic form, ax squared plus bx plus c. Plus 187d. You'll find that again going back up, 202d minus 15d. 202 minus 15 is 187. So that's where the 187d comes from. And lastly, this 505. And this all equals to k. Okay. And so what are we going to do here? We could factorize, but we'd still have this k. It's basically a constant in our equation. So let's take everything to one side again. So basically, let's take the k to the left-hand side. Minus 60 squared plus 187d plus 505. And again, just think of this k as a constant. It becomes minus k. And so this 505 minus k is basically our c term here. Now this becomes hard to factorize and hard to plug into the calculator because obviously you can't solve it having this variable k in here. Another way of solving quadratics that we haven't used yet in the paper is using the quadratic formula. So that, according to the quadratic formula, I was going to say x equals, but let's say d equals minus b plus or minus the square root of b squared minus 4ac, and this is all over 2a. So substituting in our numbers, and we could even list what a, b, and c is. So a is minus 6, b is 187, and c is, as mentioned, 505 minus k. We could even color code, so 6d squared, okay, 187, and the 505 minus k. Okay, so now we substitute in. We've got minus 187 plus or minus 187 squared root minus 4 and then minus 6, and we're running out of room here, so we're going to have to erase all this. Times 505 minus k. Okay, and that's all over 2a, which is 12 here. Minus 12, that is. Okay, so tidying up our expression, we've got minus 187 plus or minus the square root of, and we can say 187 squared is 34,969, and I suppose for the sake of working, let's write that. 969 positive 24 times, because negative 4 times negative 6 is 24. And I'm just trying to save some time. Let's multiply 24 by 505 as well. Okay, and that becomes positive 12120, and we've still got the k left over, so it's minus 24 k. Okay, and this is all over negative 12. How much room have we got? Okay, a fair amount. So again, we can simplify. We've got minus 187 plus or minus the square root of, and now we are going to add 34,000 969, 34969 plus 12,120. And that comes out to 47,089 minus 24k. Okay, and this is all over 12, negative 12 still. And so what to do here, at this point we have to think about the context of the question. And so we have got, we are looking for three conditions, the question says. A whole number k must satisfy for it to be a possible turnover for a given day. So we have stated the turnover, the equation for D, when we've got this turnover of k, let's say k dollars, a whole number k. Okay. And so we've got some rules here. The first condition, let's say number 1, the discriminant, and here I'm just pulling them from the marking schedule, and I'll explain each as we go. Discriminant must be positive. Now, why is that the case? Well, if we had a negative discriminant, there would be no solutions here. So just knowing our discriminant rules, b squared minus 4ac is the discriminant. And that has to be positive. And when that's the case, you have two solutions. Okay? Now, condition 2, it says, the marking schedule says D is rational, so 47089 minus 24k must be a square number. 47089 minus 24k, which is again the discriminant that we're talking about, is rational, and therefore Ah, 47089 minus 24k is not rational. Well, not necessarily. We're saying D is rational. And so for D to be rational, 47089 minus 24k must be a square number. Okay. And why is that the case? Well, if we are square rooting a square number, you come out with just an integer, so a whole number. And if we want D to be rational, we have to be working with whole numbers throughout our final equation here. Okay? So those are two of our conditions. Number 3 here. It says D is an integer, so okay, D is an integer. This one is probably a little bit easier to understand. And why is D an integer? Well, that is the same theory as the question earlier. D is an integer because we're talking about days here, whole days. You can't have fractions of days. And so if D is an integer, therefore, they say 187 plus or minus the root of 47089, basically minus 24k. Basically, the numerator must be divisible by the denominator, which is, of course, 12. So they want D to be an integer, basically a whole number, and so they want the numerator to be divisible by 12, which would make for a whole number product. That's constraint 3 or condition 3. Number 4, last one. They say D is positive. So again, we're talking about days here. So D is positive. You can't be dealing with negative days. D is positive. So numerator. Again, we'll say the numerator. Not number, numerator that is. Numerator has to be basically the same operation as the denominator, which in this case is negative 12. So we want the numerator to be negative. Now the marking schedule, if you go on and have a look at it, will say positive. And why does it say that? Well, they used, instead of their quadratic being negative 6d squared plus 187d plus 505 minus k, and I'm just looking at our working here. Okay, they have said, basically, they've taken away these negative signs here. And so it becomes positive 187 and positive 12, and that's why they want their numerator to be positive. We have come up with negative 187 and negative 12. And so in our case, we want our numerator to be negative. Okay, and with that, we have made all the necessary conclusions or conditions. And so for your excellence, your E8 excellence, this is an excellence question, T2 or E8, same thing, makes 2 of the listed conclusions. So 2 of these gets you an E8, making 1 of the conclusions. Let's just say the first one will get you an E7, so excellence and T1, that is. Now your merit is finding a simplified expression for D. So this step here is a merit, and you achieved rearrangement of the equation set to 0. So that is where we rearranged k for the equation to equal 0. So achieved for that. Okay. And finally, we have completed the paper. This was my first walkthrough of a level 2 algebra paper, and we've gone way over time. You're looking at 1 hour per paper, and we've gone about an hour and a half. And I'll look to get quicker in the future. But anyways, guys, I hope you enjoyed, and I hope this was of help. My explaining at some points was below par, so feel free to have a look at the marking schedule. It's all on NCEA. Anyways, though, thank you all for watching, as always, and feel free to drop any questions or comments below, and I will see you guys next time. Cheers.